I am Sarah Al-Gahtani, cybersecurity and digital student at Imam Abdul Rahman bin Faisal University. We are here to present to you our graduation project titled WhatsApp Digger. We are a group of four. I'm Sarah. Here are my colleagues Malak, Deemah, and Lamyaa. And for the agenda, we will go through the introduction, the model, and we will discuss some similar tools. We will show you a demonstration, and we will show you what makes our tool special, then what are the places for improvements. Can you go next? Okay, next. Okay, first of all, finding an idea. Actually, we are still students. We are not graduated yet. We have 2 weeks ahead to be officially graduated, and now we are in the middle of the finals, so please pray for us. Actually, we were spending the last summer looking for a problem to adopt or to address, and literally we annoy every information security expert we know. So some of our victims are here in the hall. Thank you for your cooperation. But we settled down with a problem that is reported to us by the Department of Digital Evidences in Saudi Arabia. They said that they are facing difficulties while investigating WhatsApp cases. And why WhatsApp? Exactly, not other application. Because in Saudi Arabia, more than 80% of the crimes are committed using WhatsApp alone. And this is on the local level, but in the global level, WhatsApp is accredited to be the highest or the most used messaging application ever. So, and there are a lot of research indicate or pointing out the relationship between using WhatsApp and the increase in the digital crimes. So for these two reasons, the local and the global, we were determined to address WhatsApp problem. Can you go next? Okay. First of all, before going deeper into the problem, I want to make sure that we are all on the same floor. So I will explain briefly the acquisition types, or 3 of the general acquisition types in forensics, indicating that we in forensics care about the integrity and the admissibility of the evidences in the court. Firstly, we have physical acquisition, where we try to, when there's a crime, we try to acquire the data of the suspect or the victim device. And we have a 3 method to do so. Either physical acquisition, where we retrieve all the binary representation of the data, so nothing is left in the device. So even the deleted files will be acquired. But the problem with this acquisition method is that it takes time, and it's really to decode the data and reconstruct the data again to be easy for analysis. Secondly, we have the logical acquisition type. The logical acquisition differs than the physical acquisition because it interacts with the file system level. It doesn't go deeper. And it could acquire data of a specific data object. For example, all the pictures, all the videos, all the text, and so on. But there's a subtype from it called spare acquisition. It's the same, but the difference is that it could retrieve the deleted files. Next, the last one, which is the manual acquisition, which is in the forensic field, is the least preferable methodology, because here the investigator should open the phone or the computer manually and start investigating and record the process using a video cam. So he will do it by hand. But that makes the integrity of the data suspicious, because any mistakes happen could ruin the evidence integrity, deleting the image, deleting messages, or so on. But the point of departure is that in the existing tool, there are 2 acquisition methods. Regardless of the general types, there are some certified tools, I bet you heard about it, like Celebrite and XRY. These are certified tools by the whole world, and they generate reports that is certified by the court. But the problem with these tools is that they have to acquire full image of the mobile device. So everything in the mobile should be acquired for a WhatsApp case, which at least takes 1.5 days. And then they start searching for WhatsApp artifacts, because the acquisition using this tool will mix everything together. So we'll have all WhatsApp pictures with Telegram, with Snapchat, all the text messages, and so on, which requires you to filter out related data. And lastly, you will start analysis. So it's like a 3-step process. But the better solution, or the better method for WhatsApp cases, is to just acquire WhatsApp files and you start investigating them. So we decided to adopt the second acquisition method, or the second methodology. And here's an overview about the model we proposed, or we developed actually. First of all, simply, you just plug in the suspect or the victim device to the computer. Then you will open WhatsApp Digger forensic tool. This tool will be able to access your phone to get the key for decrypting WhatsApp files, because WhatsApp database is encrypted. and then we'll acquire WhatsApp files, database, and media folder, and everything. Then it will show it to you in easy format for investigation and analysis. And in addition, it will provide investigating methodologies or features such as hashing, searching, reporting, and many. Now, I will leave the floor to my colleague Deemah to talk about the existing similar tool and NIST test assertions and the plan.
Thank you, Sarah, for introducing me. I'm Deemah. I'll continue with the WhatsApp digger story, actually. After we found the idea, we just scanned the field for the existing tools with a confidence that we won't find any tool that extract the WhatsApp files directly. But the shock was we found 4, which are GuestSub, Alchemsoft WhatsApp Explorer, WhatsApp Key Database Extractor, and Salvation Data WhatsApp Forensics. After being terrified for a while and thinking about what we can do now, we just realized that this is actually an opportunity to find the deficiencies in the existing tools and improve it and improve our tool strength to provide the field with a useful tool. To do so, we selected NIST test assertions and test plan and researchers criteria to analyze the tools, the existing tools. Okay, let's start with the first aspect, which is NIST mobile device tool, test assertions and test plan. As we all know that integrating standards and international standards and test the existing tools against international test assertions highly affect the tool certification and the evidence admissibility in court. So we selected NIST test assertions to compare. Basically, it is a general test assertions that are related to all types of forensics mobile devices, tools, that aims to evaluate the how accurate is the tool while acquiring the WhatsApp data. Basically, it consists from 2 main categories, core and optional. The core test assertion, we focused more on the core test assertions since the optional focus more in the physical acquisition, which is not used in the WhatsApp forensic field. So there's 10 test assertions, core test assertions. The first 3 are similar in the sense that they evaluate the accuracy of the acquired data, but they are varying in the scope of acquisition. The first one is related to acquire all. Acquire all means acquire all the data in the mobile device. So if the tool provides the option of acquire all the data, the tool must succeed to with this acquisition. The second test assertion is similar, but with the scope is select all. Select all means here that select all the data objects related to one data type, like selecting all the pictures related to picture data type. Okay, the third, similar to the previous, but selected objects. Here the difference is selected objects like selected pictures from the picture type itself. So like acquiring the pictures related to WhatsApp application from the whole pictures stored in the mobile device. This is the only one that is applicable to WhatsApp forensic, and the previous are not applicable. The fourth is related to the interruption. If the tool, if there is an interruption between the mobile device and the tool must notify the user that there is an interruption happened, and the user can take an action. As you can see here, this is an example from WhatsApp Digger. If an interruption or if the cable is unplugged, WhatsApp Digger will show this error or alert message to the user that you can replug the cable again. Okay, the fifth test assertion is related to review the acquired data. So the tool must be able to provide a preview pane or generated report about the acquired data. Like here, media folder is acquired from WhatsApp Digger. Here is the content of the media folder. Okay, the sixth related to providing information about the connected device, like the IMEI, the serial number, the version, the software version. As you can see here. The seventh is related to the usability of information or the data acquired. So the data, instead of just presenting dummy data and thumbnails of pictures, the tool must present useful information so the investigator can easily investigate the cases. Okay, the eighth is related to the non-Latin characters, like the Chinese, like Arabic characters. So the tool must be able to show the non-Latin characters in its native form. The ninth test assertion is related to the hashing. So the acquired data must be hashed, and the tool must provide hash value for the acquired data, either for specific data objects or for the overall case file. And the last test assertion is related to the modification. If the investigator modify the acquired data using third-party tools like hex editors or anything, then reopen this project with the tool must be able to detect such modification. And as you can see here is the result of the comparison. The most important colors here is the green and the orange. The green means that the tool passed such test assertion, and the orange means that this tool failed with this test assertion. And as you can see, there is no existing tool that passed all the test assertions. Here comes the WhatsApp Digger, which is our tool that passed all the applicable. Since, as I mentioned, the first two is not applicable for WhatsApp cases in general. Okay. As we said that NIST test assertions are general for all types of forensics devices, we had to select or define more specific criteria, like researchers' criteria, to get a comprehensive view about the existing tools, which will be explained by my colleague, Malak.
Okay. Hello. Thank you, Deemah, for introducing me. I'm Malak, and I'm going to talk about the research criteria comparison. But first of all, I want to clarify something about WhatsApp architecture. Actually, the WhatsApp artifacts are stored in SQLite databases. And for sure, it's encrypted for the security purposes. Therefore, okay. So in order to parse the database and find these artifacts, we have to decrypt it. In order to decrypt it, we have to find the key. And the problem is that the encryption key is not accessible. So we can't go through the files and extract the key and decrypt it easily. But the idea is here, or the question is here, how the previous four tools find the key and decrypt it and parse the data. They can do it by either routing or downgrading. I will start with routing. We all know that routing means we escalate the privilege, we take a system privilege. So what they did is utilize the recovery partition in Android devices and flashing custom operating system to gain routing access. Such this process have many downsides, which are either it's device dependence. It may lose or change the data, so we can't preserve the integrity. And finally, for the new devices, the bootloader is unlocked. Locked, which means we have to unlock it. In order to unlock it, we have to unlock the OEM, if you know it. And if we unlock this OEM, we have to wait 7 days, or we have to wait unlimited time, which the acquisition process will be failed. This option, it's not supported anymore. Also, the other type, which is downgrading. Downgrading means that we have to change the version of WhatsApp. We have to install the old version, which is 2.11.431. But actually, for the new WhatsApp, force us to install the newest version. So also, this option is no more supported. We take in mind these two points with other criteria to build this table. As you can see, this is the comparison between the four tools. As you can see here also, some of them lack the opportunity to parse the media, picture, videos, calls, and so on. Also, they can't provide hash feature. Also, for project arrangements, they didn't support it, which is very important for investigator to arrange all the files related to the one case in one project. Next, please. Okay, but once we put WhatsApp Digger, it satisfies all these features, alhamdulillah. Thank you. Thank you. Now it's the demo. Our demo, we divided into two parts. We start up with the video. We acquire the WhatsApp artifacts. We decrypt it, and we show it. The live demo, we will show you how we open a saved project and do the other features, the analysis features. So we will start the video. Actually, first of all, we have to create a project. We have to provide these four information: case ID, case name, investigator name, and description. This will help you once you generate the reports. Then we have to acquire image. Once the acquisition, it's divided into two parts. We have to verify the device connectivity first, which take less than 1 minute. This verification, we use it in order to show the information needed for the device, like IMI and other, to satisfy one of the test assertions. As you can see here, can you stop? Okay. Yeah, as you can see here, we show information about the device, software version, device model, serial number, IMI, and service provider. So we alhamdulillah satisfy one of the test assertions. Also, now we start the acquisition, but before we have to give a name for this image. Okay, so now the acquisition process will start. It will take 1.5 minutes. It will acquire the encrypted database, which is SQLite, and it will be decrypted until it will shown here in the right side with a node, with the name that we already provided, and the artifacts will be below this, the node of the image. So the acquisition process is completed, alhamdulillah. Okay, this is the hash value. Actually, this once we acquire database, we have to calculate the hash, and this hash will be used for the future references, inshallah. Okay, now this is the database, and all the artifacts will be listed below. Then we saved this project in order to open it for further analysis, because we will now do a live demo, and we will open this project, and we will explain more features. Okay. So this is the interface. In order to open the saved project, we have to go File, Open a Project. Then we have to specify the project that we already saved, which is OPCDE. So this is the image that we already acquired. As you can see here, we divide the nodes, chats, locations, pictures, and all the media type. So once we expand this chats, we will see many nodes. Each node specifies the specific conversation. So if we press this node, we will show this conversation done by owner and this phone number. We mean by owner is that the one that we acquire image from it. So as you can see here, there's Arabic letters. So also our tool, it's not limited to the English letter, also for non-Lithuanian letters. Okay. Also a location, but for this image there is no location. But if you find the location, we'll list all this information, latitude and longitude. Also for pictures, this is the picture who's sent and who's received. Easily by double-click it, it will use the default applier of your computer and it will show the image for it. Okay, as for the voice node, we will double-click on it, and it will, I don't know if you hear it, but it will also use the it will use the default applier and it will run it. Also for the videos, audios, document. As for document also, we can double-click on it and it will show this document. What else? Yes, for the calls also, you can see here all the calls. Who's starting who's the one who called the other, and if it's answered, missed, declined, and many other things. Okay, this is for the parsing. The other thing, it's the bookmark. What does mean bookmark? We mean that instead of let the investigator each time to go through all the artifacts, he can easily select the suspicious file or the evidences and list it here for easy reference. So let's consider for this one, we think that it is suspicious. We double-click on it, then we go to action, add to bookmark list. We have to specify if it is certain evidence or suspicious. Let's consider it suspicious. So you can see it here. This is the one that we added. We can change the color if we know certain that it's evidence, and we can delete it if it doesn't indicate anything. So in case we change it, it will change the color. So the thing is that in case the investigator done with the investigation, he can generate the report, and all the evidences listed here with the red color will be directly added to the report. So from action, generate reports, we can generate it in Arabic or English language. I will show you the English one. So this is the reports. We have to fill this information. Actually, we specify this information based because we analyzed lots of the investigation process, and we adapt the thing that we think is related to our case. So as you can see here, the case ID, the case description, investigator name, that we already specify it once we create a project. It automatically should be added. Also here, he has the investigator should write anything about the investigation process, also for the conclusion and many other things. As you can see here, this is the evidences that we already choose as a certain evidence. So it will be listed automatically here. Once the information is filled, we will save the added information. It will be saved, and it will export a report. And this report will be used to submit it to the court. That's all for the demo. Okay, I forget something important. So for the search, of course, we can search for a specific number or for a specific word to easy find. So as you can see, I only I. So it will list all the messages that contain this letter. As for the hash as well, we can click this image, for example, and we have to calculate hash, and this is the hash corresponding to this file. That's all. And now my colleague Lamyaa will continue with you.
Thank you, Malak, for introducing me. I'm going to continue with you with the last part of our presentation.
So first of all, we mentioned many tools earlier. I'm going to talk to you about what makes our tool special. First of all, the key access method. As my colleagues mentioned, the database that is stored in the, in the victim or the suspect device is encrypted. So we have to get the decryption key. How we can get it? By either rooting or downgrading. But those methods have their own disadvantages. So we came up with our own workaround to get the key, such that it preserves the integrity and it keeps the evidence intact, and yeah, and and it is currently under patent, so we cannot expose more details about it. Yeah. The second thing is that our tool proves to be efficient. We measured its efficiency against two factors, which are short response time and minimal use of resources. For the short response time, we compared our tool against other tools, and we calculated the average short response time against two criterions, which are device connectivity and the acquisition part. For the device connectivity, we connect the suspect device, and we calculated the average time for our tool to detect that there is a connected device. And the average short response time is around 15 seconds. For the acquisition time, the total time is around 40 seconds. Also, our tool have a minimal use of resources. The total space for our tool is around 1600 kilobytes, which is considerably low. For the data integrity, we ensured that the acquired WhatsApp files are the same as the one acquired with our tool. So we calculated the hash value that resides in the victim or the suspect device, and we compared that hash value with the one that we acquired using our tool. And they were the same. So our tool preserved the data integrity. For the reliability is defined as the time between the interruption and the resumption. So we run our tool and we tested it against two criterion, the device connectivity interruption. So when we unplug the device, the time for our tool to recognize that there is an interruption is around 7 seconds. And during the acquisition, if there is an interruption, the tool will detect that there is interruption in around 5 seconds. For the ease of use, we show our tool for the digital investigators and the digital criminal evidence in Saudi Arabia, and they specify that it is easy to use. They find it easy to use, and our supervisors give us a good feedbacks around that. For the maintainability, our tool is up to date with current mobile forensics tool, and one of the examples is the bookmark. Now for the security implementation. We show you in the demo earlier that we use SHA-512 algorithm. Why we use this algorithm specifically? Because it has an invisible collision attack. What do I mean by collision attack is that two files have the same hash value. So in SHA-512, it is invisible, so it is not detected yet. So, wait, okay. Okay, so this attack does exist in all hashing algorithms, and it was a shock for me to know that all hash algorithms have collision attack. But the core here is to make this, it hard to find. So the generated samples, to have a collision, we have to generate around 2 to the power of 256 samples, which will take around 1.22 years to find a collision. So we implemented SHA-512 to ensure that the files that exist in the investigator's workstation doesn't collide with each other, and thus saving the data integrity. For the challenges, of course, any project has many challenges.
And one of the challenges that we face is SQLite database structure. Some columns were vague, and we didn't know what they represent. Some just have numbers, and and when we read and when we scanned many papers, they didn't indicate what they mean exactly. So to solve this challenge, we have to conduct small experiments several times until and then we compared it with the last database to see what this number indicates exactly. And I will clarify this more with this example. So media WA type, we didn't know to represent what and other numbers. So we sent photos or audios, and then we saw this media WA type column to see what is really represents. What does it really represent? And the second challenge that we face is to parse database files. Some media files doesn't have name, like here, it is represented in null. So we refer to another table, and we look for the blob, for the thumb image, and we look for the blob hex representation, and in the string we find the media name, which will help the investigator to know more about the evidence. This challenge was very hard for us. One of the laptops, during our experiments, one of the laptops was formatted, and not once, it was formatted twice. So all the WhatsApp Digger codes were erased, and most important files were erased. But luckily, we have iCloud backup on some files. And for the last WhatsApp Digger, we had to recode it again. Also, as you saw earlier, we had to save our project, and the extension to save our project is using XML format. We faced the challenge in choosing the specified extension, since most of the tools use proprietary format like DD and EF, but it was hard to program our own extension. But we find that XML do the job. So we serialize the important objects like bookmark and many objects like project name, case name, and so on. So we serialize those objects and we save them in XML file. And when we retrieve the project again, we unserialize them. So it is represented in easy format. So what next for WhatsApp Digger? We will create our own proprietary format. We will include iOS devices, since our scope just covers Android devices. We will retrieve deleted messages and log files. So to conclude, we presented our tool, we presented the similar tools, and we present to you Nist's assertions, and our tool satisfies most of them, all of them. And one important lesson is that always back up your data. 2 is 1 and 1 is none. And that's it. Thank you for listening, and we are glad to receive any question.